recording so that we can go back over this and take a look at it again. I checked the discussions board this morning and my email, and it seems most people are the thing topic that came up. Most people was concerns about um, uh, uh, assignment 1 and 2, and particularly assignment 1, which most of you, which is I guess due tonight, and a couple of particular questions. One in particular was question number 5, in which you had to interpret a histogram, which was a little tricky. In fact, you may have noticed that I altered the problem to let you know that there's issues with that. We've had issues with it in the past. So I just gave full credit to everybody on that, but you could play around with it. But I'm going to go over that anyway to so that you understand what that was about. And the other thing was some issues still with SPSS and understanding how to use it to answer those couple of questions that were on assignment 1. And then I'm going to freelance a little bit and maybe get into some stuff that I know has been problems in the past. If you have specific questions, you can type them into the chat box. I've muted your microphones, and the reason for that is that once we get more than a couple of people on, there tends to be a lot of background noise and so on and so forth that winds up in the recording, so it doesn't manage very well. Sometimes, occasionally, when we have a session, and especially right after a test, so, only 1 or 2 people might show up to an online session. Others might hold out for the recording, and then I can leave the microphones turned on because it's a little bit more intimate of a setting. But for now, please use the chat box if you have questions as we progress through this. Okay, so are you guys okay with that? Is that something you think we can work with? Okay, remember, my only feedback from you guys is what you put in the chat box. So if I ask a question, you gotta type something to the chat box. Uh, okay, good. I appreciate it. Thank you very much. Okay, I'm going to go ahead and I'm going to get started with assignment number 1, which I'm going to have to hover over this and see if this is assignment number 1. This is assignment 2. Let me get to assignment 1. It's back here somewhere. There it is. Okay, this is PDF, pretty small PDF version of it, so I'm going to have to zoom into it. Now, at the beginning, just to go through in these first week or 2 of this course, we're not really getting into real statistical testing at this stage yet, but we're getting familiar with really important concepts. And one of the really important concepts is this idea of different data types, different ways that data is stored, different ways that it's used, different ways that it's organized. And that's really important to us in the long run, because when we have nominal data like gender, like hair color, like handedness, left-handed or right-handed, when we have nominal data like that, which is basically names or categories, nominal data often is also referred to as categorical data. Categories, names, kind of the same thing. When we have that kind of data, we handle it very differently than we handle numerical data, like blood pressure, like blood sugar, like blood lead levels, like, and so on and so forth, like parts per million of chemical in the environment or something like that. So we handle those numerical variables using different statistical tests than we use when we work with categorical variables. And so really the 2 main classifications that we use when we are looking at data is we're looking at categorical and nominal variables. We're looking at numerical variables. Within those groups, we can break them down a little further. The categorical variables, like, for instance, hair color, for instance, brown, blonde, brunette, so on and so forth. Those names, those values for those variables, right? They have equal weight. They're just names, basically. Okay, so we can have another kind of categorical variable where even though it's a name or a word, it represents some order. It represents some relative value. Not a specific value like numbers do, but kind of a relative value, one value to the other. For instance, a grading system: fair, poor, fair, good, excellent. Right? Now, those are categories, right? Each one of those is a name or a category, but they have the added importance that they have an order. Presumably, good is better than fair, excellent is better than good, and so on and so forth. Even though they're categories, they have some order. So we group those into a special thing called ordinal variables. So now we have nominal or categorical, and we have ordinal variables, a form of categorical. Okay, so in numerical variables, we have scalar variables, things that are in a scale, like blood pressure is 80.2 and 101, or so on and so forth, that have a definite scale. And we have, within that group, we have discrete numerical variables. Discrete numerical variables are variables that typically are integers, low numbers of integers. For instance, the number of siblings that you have. If you have 3 siblings, 4 siblings, 1 sibling, none, right? Those are numeric. They're numbers, but they're whole numbers. They usually you're not going to have 3.2 siblings. On the other hand, if I asked you what was the average number of siblings in average number of siblings and families in New York State versus New Jersey versus Connecticut, you might wind up and say, oh, 2.1 in New York, 3.14 in Connecticut, and so on and so forth. Those would be numerical variables because they are no longer integers because they're average. They turned out to be averages. So it's a little confusing in the beginning, but that's really kind of where we stand with this kind of stuff. Primarily, we're interested in categorical or nominal. You could use either name, numerical or scalar, and ordinal. In fact, when you use SPSS, in order to get SPSS to work correctly, you identify the variable type for it. So, and SPSS only looks at 3 different variables: not nominal or categorical, ordinal, or scalar, the way it calls it, the word that it uses for numerical. So those are the main categories. But we play around with a little bit here so that so that you get used to identifying the different kinds of variables. So let's take a look at assignment 1. Now, instead of just throwing out questions, instead of just throwing out answers here, let's talk about what each one of these variables are. Now, note that which of the following categorical variables select two correct answers. I gave you hints that there's 2 of these answers are correct, right? So anytime you see a question on Blackboard that has boxes instead of circles, the circles, they call those radio buttons. You can only push one. If you push one, the other one goes off. These you can check as many as you want. So we gave you a heads up that there's only 2 correct answers here and so on. So most of these are boxes where you select that. So I'm just going to go through all of these variables and discuss it with you. Okay, country of origin. What do you guys think what kind of variable do you think that might be? Right, Poland, Hungary, Russia, Italy, right? Those are categorical variables, nominal or categorical variables, right? How many siblings do you have? Well, I just gave that away, didn't I? That's a discrete numerical variable. You could also just call it numerical, but more properly, it's a discrete numerical variable. Do you smoke? Right? What would be the answers to that question? Do you smoke? Yes or no? Right? Now, if I asked you, which again, nominal variable, right? If I asked you how many cigarettes a day you smoked, now we would be talking about a numerical variable, right? And since it's probably not going to be 1 or 2, it's going to be a big number. It could be a big number, 40 or 20 or something like that. I probably might not call that discrete. You could, I guess, get away with calling discrete, but I would stick probably with numerical. How many cups of coffee did you drink this week? Okay, well, that's a numerical variable. You could probably get away with calling either one of these numerical or discrete. Okay, what's your blood pressure? Well, that's going to be a scalar variable, right? Numerical variable. How would you rate the MPH program? Excellent, good, fair, poor. You guys tell me what that is. What kind of variable is that? But the boldest among Danielle, the boldest among you, right? It's an ordinal variable, right? See, it's not that hard, is it? The only confusing thing is that this idea of breaking up numerical variables into discrete and numerical, choosing one of those, that's a little tricky, but really in the long run doesn't really make that much difference. Country of origin, we just mentioned was nominal. How many siblings do you smoke? How many whole cups of coffee did you drink today? In whole numbers, that would be obviously the trick there is I'm trying to highlight that it's a discrete numerical variable, blood pressure, and so on and so forth. Let's see if there's any different ones in here. What is the average number? Now, cups of coffee was discrete numerical variable. How many you drank today? How many was the average number of cups of coffee you drink per day, calculated by averaging your daily consumption for a week? What kind of variable would that be? right? That's no longer necessarily going to be a whole number, so we would call that a numerical or scalar variable. Blood lead level, right? That's going to be a number, right? In other words, if you guys are in public health, you probably know that that the current action level for blood lead level in children is, I believe, 5 micrograms, 5 billionths of a gram per deciliter of blood, right? So that's that. And if a child might, a scalar, exactly, scalar and numerical. Okay, do you smoke? Yes or no? Now, a yes or a no, an answer there, simple answer like yes or no, that is a categorical variable, categorical or nominal variable, right? It's a yes or a no, even though it's a kind of a positive or negative kind of thing. That one's interesting. That's a dichotomous nominal variable, categorical variable. Means it has two values. We run into a lot of those. I didn't ask you to describe it as dichotomous for this purpose, but we're going to run into a lot of those because if you deal with disease or if you deal with an exposure, a lot of times you're looking at whether it occurred or whether it didn't occur, whether it's true or false, whether it's male or female, whether it's and so on and so forth. So there's a lot of variables, whether someone has diabetes or doesn't have diabetes, whether someone has asthma or doesn't have asthma. So we're going to be working with those variables, those dichotomous variables, in a special way. There's something called the binomial distribution, the way that chance influences when you sample a population and you look for variables that are involving two values like that. What are the last 4 digits of your social security number? Right? Well, that's kind of a tricky one, isn't it? Last 4 numbers of your social security number. You don't use those as numbers, do you? What do you use your social security? What purpose do you use your social security number for? You use it to identify yourself, right? You fill out a form, you put in your social security number that identifies you. Those last 4 digits of your social security number, those are actually, even though they're numbers, that's actually a categorical variable. The number itself has no meaning, and the last one number, the digits of your social security number, do not indicate your BMI or your weight. They've been randomly assigned to you, so they are just like any other name or nominal variable. What's your blood pressure, and so on and so forth. Let's see if we got any other new ones here. I don't think there's any other different ones here that you don't get previously. So you should be able to go back through this. And for instance, which of the following are ordinal variables, right? Ordinal variables. Scale of 1 to 10, how much pain are you experiencing? Even though that is a number, right? It really each number represents a level of pain. It's kind of it's a name, like a lot of pain, a little pain, more pain, but it's indicated as a number. And the interesting thing about this is that it's an ordinal variable because it indicates a level, a different level, right? They're in order. Pain level of 8 is greater than pain level of 7, but it's not really a scalar variable. One of the reasons it's not really a scalar variable is because it doesn't have the properties that a normal number scale has. For instance, your one person's number 3 level of pain might be another person's number 5. So you really can compare them as numbers, even though they're described as numbers. And numbers really represent names that have order, right? So for instance, again, also, even a particular person, if it comes into the emergency room at pain level of 8, and you give them 2 aspirin, and after about 15 minutes, you go back to him. He says, "What's your pain level now?" And he says 5. Well, we don't know if the difference between pain level 8 and 5 is the same as the pain level difference between 5 and 2, right? It may not be actually like when you're talking about weight, the difference between 90 pounds and 80 pounds and 60 pounds and 50 pounds, those differences are both 10 pounds. They're the same. But with ordinal variables, all we know is order. We really can't relate really specific numerical variables to them, even though that one is a tricky one, and they use a number to represent the name of the level of pain. Okay, so let's move on to the next question. Now, question 5 has caused enormous consternation, and I put in a thing. This question has been modified. You get full credit. I'll replace it in future homework. I'll go over it sometime in the future, maybe before our first exam, and give you a different chart. I have a few different charts here. I'm not sure which one that you guys got. Presidents.pdf, was that it? Uh, I'm going to use that one. I don't know if this is the particular one that you guys got or not. So what we were trying to describe here, or encourage you to do, is look at a histogram and understand what the axes of the histogram represent. On a histogram, the x-axis represents the number range, right? Age 40 to 44, age 45 to 49. So on the day before your 45th birthday, you would be in this bar. On the day you have your 41st birthday, you would be in this bar. So you would never be between bars. You'd either be in one or the other. That's why, unlike bar charts, which you use for categorical variables, hair color, and so on and so forth, there's no spaces between these bars because you're in one or the other. Okay, so each one of these represents the age range, the range of ages that a particular president might have been when he was first inaugurated. That's an older chart, so it doesn't have all the presidents, I don't think. The y-axis represents the frequency, the number of presidents that fall into that category. So if we look at this, there are two presidents in the United States history that were between 40 and 44. I know John Kennedy was one of them. I don't know who the other was. It might have been Jefferson, perhaps. I don't remember. One of you guys might want to look that up sometime. Maybe you don't want to look it up. We're good statistics class here. I don't want to encourage you to go off on a tangent for now. So there were two presidents. But between 45 and 49, we had five presidents. Between 50 and 54, we had 10 presidents. So the height of the bar represents the frequency, the number of people, the number of subjects, the number of outcomes within that range that we have on the x-axis. So if I add these all together, 2 and 5 is 7, and 10 is 17, and another 17 is 34, and 5 is 39, and 4 is 43, and 1 is 45. So I believe that the total here is 45. Feel free to correct me in the chat box if I got that wrong. So the question was, and this is, we've been using this for a long time. I think that we really probably should ditch it and ask some more realistic questions. The question was, for instance, in which one of these bars would you find the median age for a president? The middle age, right? Not the average age, the middle age for a president. It might be difficult to figure out what the average would be here from here because we don't know the exact ages themselves, right? So the median age, the middle age, that would be, in other words, 45 presidents. That would be the 23rd oldest president when he took office, right? So where would the 23rd oldest president be? I could count up or down from to the 23rd president. So the two youngest, two we have there. We have 5 here, so that's 7. So we go from the first president to the 7th oldest president here. Now 10, we go from the first oldest to the 17th oldest president between these three bars. So it's 17 presidents that were under 55. And then we have 10 presidents. So we have the president was the 18th oldest all the way up to the 34th oldest. So the 23rd oldest president, the median age president, is going to be inside this bar somewhere. So the answer to that would have been 55 to 59. I don't know what else we have. Do we have percentiles there or something like that? Let me take a look. The median age for president. What proportion of the presidents of your answer? What proportion of presidents were 45 of these 45 were 60 years or older at their inauguration? Okay, so how many presidents were 60? We have 45 presidents. What proportion of presidents were 60 years or older? Well, we have 45 presidents. We have 5, 9, 10 presidents that were older than 60, right? 60 or older. So 10 out of 45. So 10 out of 45 is, I see a question pop up there. I'll get to it in a second. Let me just finish this calculation. Yep, what happened to my calculator? There it is. 10 divided by 45 is 22% of the presidents were older than 60 at their inauguration. Let me see if the question was there. I got to move this over. What do you do when you have two medians? Why would you have two medians? I'm not sure I understand that question. The median is the middle. Oh, I'm sorry. I do understand that question, and it makes sense. Oh, I understand. Yes, yes, I get it. Okay. For instance, let's say that we had a list of numbers. Let's say we had 10 people. We wanted to find the median of 10 values, right? Well, there is no middle number there, right? The only way you have middle numbers, you have an odd number of subjects. For instance, 11. The middle would be the number sixth person because there's five above them and five below them. What you do in that case is you just take the two middle ones. For instance, in the case of 10 numbers, it would be the fifth and the sixth individual, and you would average those two. And the average of those, the fifth and the sixth individual, would be your median value. Your median value doesn't actually have to have a physical representation. It can be an average of the two middle values if you're dealing with an even numbered list. Does that help? Okay, good, excellent. Good question, by the way. Okay, next. Let's see what we have here. You can't see it here because SPSS does weird stuff Blackboard does weird stuff when you make a PDF file out of an exam. So it drops in all sorts of weird boxes. But the gist of I think the next question was something about percentiles. In other words, where would the 25th percentile president be? Well, the 25th percentile, the median is the 50th percentile. He was the 20, what would I say was he was the 23rd president, 23rd oldest president. So the 25th percentile would be between the 23rd president and the first president, right? So that would be kind of like half of 23, which would be roughly about 11, right? So he would be the 11th oldest president, roughly, right? So the 11th oldest president is going to be, let's see, 2 and 5 is 7. He's going to be in the bar 50 to 54. What about the 75th percentile? Well, the 75th percentile would be between the median value, which was 23, I believe, 23, I think it was, yes, 23, and the oldest, who was 45. So you want to know something? Rather than go that way, I can come down 25% of the presidents, in other words, 11 presidents, and go to the left. And let's see, we got 1, and we got 5, and we got, what's 4 rather, that's 5, 10. So the 75th percentile president is going to be in the 55 to 59 age range, just like the median. The median may be the 23rd guy, and this guy is like the 32nd guy or something like that. So they both wind up in this box, strangely enough, right? So that's the percentiles. That's how I might describe that. Remember, like percentile represents what percentage of the subjects or grades were above you versus below you. So if you're on the SATs, you were in the 80th percentile, 80% of the people's grades would be below you, 20% of the people's grades would be above you. Okay, so same thing there, kind of an odd outcome to that. The last question here is really the most relevant to what we're going to be, perhaps the most relevant to what we're going to be doing going forward. Okay, what if I asked you, when the first time I made this, I didn't make this up, we made this up. I want to blame myself, I had help on this. Last time I made this up, we were describing what if, what's if a president, given that a president is collecting Social Security, right? Given that a president is collecting Social Security, what's the probability that he's older than 70 years old? Ah, conditional probability. Given the condition that he's collecting Social Security, in other words, he's older than 65. I don't want to get into a debate about 62, 70, whatever. For most people, who knows when we made this up, 65 was retirement age. For you guys, who knows? For me, it's 66. For you guys, it may be 88, but hopefully that means that life expectancy will be 120 years by the time you get to that point. Not that they ran out of money and they won't give it to you until you're 88. So at any rate, anyway, the question was, given that he's collecting Social Security, and in parentheses, he's older than 65, right? That would mean, given that he's in only these two bars, what's the probability that he's over 70, that he's in this bar? That's a conditional probability. So we can ignore the rest of this bar chart and just say to ourselves that, well, there's 5 presidents that were over 65. Only one of them was older than 70. So the probability that he's over 70, given that he's collecting Social Security, is 1 out of 5 or 20%. Okay, so we've beaten that to death. I hope that it makes more sense doing this rather than having you worry about answering the question and get the answer right. So that's what we were after when we did this. There may be on exam 1, there may be a chart similar to this, but I'll make sure that it's a bit clearer so that you're not getting weird results like the 75th percentile and the median in the same bar. But that's the approach that we'll be using. So I hope that helps on that question, at least anyway. Okay, so moving forward, the next 3 questions, 3 or 4 questions, deal with becoming familiar. We're using SPSS and Excel. In other words, I wanted you to make sure, and the reason why this went into first homework is to kind of prod you into getting your act together and getting access to Excel, and somehow or other getting either buying or getting access to SPSS so you have it going forward. So that's the reason why I did that. So I'm gonna go back here, and I'm gonna open up the student test score file in Excel. Okay, you can open it by double clicking on it if an Excel file. If your computer, if you did a good install on your computer, and sometimes it's a little problematic, the postscript on the file XLSX, it may appear on your computer, may not, depending on how you get it, how you have your computer set up. Even if it doesn't appear, the computer should understand that that's an Excel file. If it doesn't, occasionally that will happen. If it doesn't, it doesn't realize it's an Excel file. So when you double click on it, it'll open up in some other program, or it'll say, I don't know what program to open that in, right? So, but that's not a big problem. What you can do instead, in that case, is you can start Excel, right? Start up Excel first, as I did here. Start up Excel first, then go to File, Open, Navigate. I'm going to go to Desktop. Your PC is going to look a little bit different, but it works the same way. You're going to do it on the Navigate page, and then find that file and just open it from there. Okay, this is going to open a second copy of it for me, right? It'll work just as well. Okay, but it's nice. It's nice and convenient to be able to just double click that, have it open the file, but it's not completely necessary. Okay, and there's ways to, if you want to get into it and play with it. We don't have time right now to deal with that. There's ways to identify the file type for the computer, so in the future it knows that that's an Excel file. Okay, so here we have a series of scores, 20 scores on a test presumably, and I asked you to calculate various statistics here based on this score. Okay, is there a particular statistic here that you guys have problems with? Maybe percentiles or median or something like that? Is there one in particular that, one or two in particular that cause an issue? Okay, I don't see a response, but I'll continue. Okay, sometimes there's a little bit of lag, sometimes there's just no response. Okay, run through all of them. Oh my God. Okay, I'll give it a try. Okay, so now the point here is that there's one exercise. Some of you guys saw that we did this live with some of you in the lab, and some of you just saw this on a video. But we did a version of this where we actually calculated each one of these things manually. Like we found the average, the mean, and we found the difference and squared them and so on and so forth. All of you saw this in one form or another. depending on what class you're in. However, in real life, you would not bother doing that. That was a demonstration so you'd understand the origin of some of these statistical terms, right? But in real life, what you would do is you would use built-in functions in Excel. In Excel, so I can go up here and I can click on this little f of x button. Again, PC or Mac, it might be a different position or something like that, but it really works pretty much the same way. Fortunately, they're getting there. It's getting to the point where they're kind of merging almost they almost work. They use the same hardware, the same processor, the same memory, so they're really kind of getting very similar. So at any rate, except for the user interface, which they like to play around with. So at any rate, there's many different functions in here that we can see, and they're grouped in here by the types of functions, the time functions, financial functions, and so on and so forth. If I scroll down far enough, I'll find statistical functions. Average, average A, binom, chi-square. These are different tests we're going to be working with. Simple thing like a count, how many people are there, and so on. F distributions, median, there's max, maximum, minimum, range. I think range is in there. Quartiles, so on and so forth. There's lots of them. I'm gonna go through the core of these things, and you can either click in here, or pick a simple one like count, right? You can click in here, and we can. It'll give you a description of how to use this, okay? And if in my version here, yours might be different. It's telling me if I want to start it from here, just double click there, right? And it actually opens up and lets me fill in the first value or all the different values that I want. Okay, so the values I'm interested in go from A2 to A21. So I would fill in here A2 to A21. Okay, and it gives me a little space here where if there's another group of numbers I want to include there, it'll let me fill it in there too. I'm just going to hit enter, and it gives me the average is 20. Now, the other thing you can do with these numbers is, for instance, you can go in here and you go to format and format that cell, and you can format a lot of stuff there in that cell. What kind of data it is, the alignment, whether it's centered, centered vertically, the font that you use. We're interested in a number right now. Right now, it's a number, and we want to make sure that we haven't lost any decimal places. For the purposes of this, I'm just going to call it one decimal place. And I'm only doing that because I didn't know if that 20 was a 20 or if it was a single decimal place. You can also do that for an entire column. Format, cells, number. I'll make that one decimal place. Now, anything calculation I do in that cell is going to round off to one decimal place. Now, the interesting thing is that even if oh, that was count, by the way. That was going to round up being a whole number anyway. Even if I rounded this to one decimal place, if the answer contains 9 decimal places, Excel would not throw that data away. If you base a calculation on that cell, in other words, say that I want to multiply it by 3, it will remember all those extra decimal places and include it in the calculation. So you can afford to, make this a little easier to read by displaying fewer decimal places and still not lose the data that's stored in it. So count there's 20 people in this sample. Okay, so we're gonna find now we want to find the mean, average. As it happens, it doesn't call SPSS. Excel does not call the mean. The mean, they call it the average, the arithmetic average. So now I have to put in again. I have to repeat that A2 for A21. Anytime I type something in, especially me, as you'll find you go through the semester, I type something in, I got a high chance of making an error, right? So instead, I'm going to ask SPSS to fill that in for me. Okay, oops, I shouldn't have done. I wanted to increase the size. I'm going to do this first. Parentheses, average parentheses. Now, instead of typing in A1, A2 through A21, I can click and hold down and drag, and it'll fill it in for me. Okay, and then close parentheses and hit enter. I did something. Oh, I did something weird there. I put an extra parentheses in. Hit none. Oops. I got to say okay first. Wrong direction. There we go. And the average is 77.7. Right? And instead of putting the number up here in this box, it shows you, oh, that's a calculation. That's an average of these numbers here. And the number itself is over there. So that is the means. Okay. I'm gonna redo this so that I can keep it organized. Okay, good. Okay, now let me make this a little easier to see too. There we go. That's much better. Okay, what about the median? The other one of the other measures of the central value for this distribution is the median, and there is a function called median. Notice that it helps me out. Once I put in the equal sign, it realizes that I want to do a calculation. Okay, so if I start typing, I think it's median. It shows me all the ones that begin with S, and as I proceed, it says, oh, the only one that's left after you get to that is median. So now, see, it's waiting for me to tell it where the numbers are located. So I'm going to click again and do my thing here, and the median value is 78.5. Interestingly enough, as I would mention before, this is an even number of people that's in here. So instead of giving me a particular value, it gave me an average between the two people that represented the middle values. They're not in order, so it's hard to see here. But yeah, it must have been the middle two people in here, the 10th and the 11th person, must have been 78 and 79. So it came up to 79 and a half. Median, let's see what else I can come up with here in terms of the now let's look at the spread, how variable these numbers are. So let's see, one of the things I could look at is what's the minimum value versus the maximum value. And I'm going to say, okay, let's see, A2, A21, and the minimum value is 57. What's the maximum value? Well, in fact, let's see, yeah, there is a function called max. Parentheses, maximum value, hit enter. We've got the minimum and the maximum. Well, now, what's in between the minimum and the max? What's the difference between the minimum and the maximum? That's called the range. And the range is the difference between the maximum value minus the minimum value, which is 37. Okay, so the range is 37. So if I have another group of people and I find the minimum and maximum, the range is 54, I know that the minimum and maximum is that much further apart. Okay, well, how about what other measures of variability do we have? Well, we have standard deviation. Let's see, standardized, nope. This is a tricky one. It's standard DEV. Now, there's different versions of standard deviation, .p, .s, and so on and so forth. For our purposes, I would not worry about that. If you want to read about them in the little help button that comes up when you when you hit F of X, you can do that. But for our purposes, just STDEV will do. And now it's waiting for me to put in the range of numbers. Okay, hit enter. That's the one we're going to use the most often for describing the variability. Now notice that, what happened there? I thought I had formatted this whole column. I must have changed something. Okay, let's make it one decimal place. And notice that that's there. Okay. There we go. All right, make it a little bit easier to read. And the other thing, I'll center it. Why not? Okay, so standard deviation. I skipped over a precursor that when we calculated standard deviation, doing it the hard way, by calculating all the differences in the means in each individual value, I skipped over about the statistic called variance, right? And the variance, the standard deviation is the square root of the variance. So I'll bet you that the variance is going to be, let's see, 8 times 8 would be 64, 9 times 9 would be 81, somewhere between 64 and 91. Let's see if I can't make that work out. The variance, in fact, is 71.3. It's between those two numbers. Okay, so the square root of the variance, and I could actually calculate that now too. I'll do the standard deviation that way. Okay, let's see. It's equal to standard deviation. It's equal to the square root. Now this is a math function, right? It's going to be in a math function. Square root parentheses 71.3, and look, it comes out to be the same as the standard deviation. So that really works there. Okay, now the other thing I think I asked you to do is percentiles, right? Like 25th percentile. The median we already know. This is the fifth. This is the same thing as the 50th percentile, right? 50% of the people are below it, 50% of the people are above it. But now what about the 25th percentile, right? That's the bottom of that box, the bottom of that gray box or the blue box, whatever color comes out on your computer. That's the bottom of that box would be the 25th percentile. And the top of that box would be the 75th percentile, and the fat bar in the middle would be, black bar in the middle would be the median or the 50th percentile. So let's calculate the 25th percentile. Okay, so 25th percentile, see if there's a function per, well, here we go, percentile. Okay, and the way that we calculate this is we tell it the range of numbers, right, like that, comma, and then we tell it what percentile we want. And the percentile is put in as a decimal place, 0.25, 25th percentile. And the 25th percentile is 72.8. You know, occasionally you might see a little bit of a difference in the percentiles or in the interquartile range between Excel and SPSS because they just calculated it a little bit differently. Okay, so the 75th percentile, what would the 75th percentile be? Okay, is equal to, okay, and I'm going to type in percentile. And I'm going to put in percent. Notice if I do it this way, I wait until the end to put in that percentile. It gives me a hint. It wants an array and it wants K. K is that percentile, that percentage. Okay, so I'm going to go up here. The array is a list of numbers, comma, 0.75, close parentheses. Okay, and 70th percentile is 82.3, and the 25th was that. Well, let me see, equals, what's the difference? 82.3, 75th percentile minus the 25th percentile, I get a number 9.5. Kind of like a range, except that it's for percentiles. Anybody remember what that's called? I'm going to wait for an answer here. Either say, I don't remember, or tell me what it's called. Ah, great. Thank you, Danielle. It's the interquartile range, right? In other words, it's between the middle 50% interquartile range. Okay, if I had a box plot, well, I'm going to be showing you a box plot in a couple of minutes. So I think I got most of these. I might have missed a function. Did I miss anything? I'm not sure I did. I may have. You never know. Okay, good. I didn't miss anything. Excellent. So I'm going to close this. Now the next question asks you to repeat this using an SPSS file, the same data in an SPSS file. Okay, now there's two ways I could get to this SPSS file. One way is I could double click on, you can see it over there, right here on my screen here, student test score, right? I could double click on that and open SPSS, or I could double click on SPSS and open it, or click on SPSS, open it, and it will come up with a opening window. Come on, don't keep me waiting. Uh-oh, I hope you guys are still there. I seem to have run into a problem here. Let's quit this. Okay, I seem to have run into. You guys are still there? Are you still online? I want to make sure I didn't freeze here. Okay, good. Let me try that again. SPSS did not cooperate there. Let me close Excel in case it's messing with me. Okay, let's try that again. give it another moment. There it is. It just ducked down on me for some reason. Okay, so there's the opening window. You can click this away. Don't show this again in the future. I'm leaving it here because students often see that when they start up. It shows me I recently used files. It shows me, they ask me if one way. You don't need to use that if you don't want to. You can just go, thanks for the warning. You can just go to to an empty data set where you can start typing in information. Okay, the other ways I could have double clicked on that file. One of the ways I can get data into here, I could say, oh, file, open existing data. I could say new, but in this case, I want to open existing data. And I can open SAV files, SPSS files, Excel files. I can open SAS files. I can open all sorts of other kinds of files. But it'll only show me in my window, it'll only show me files of its own type of SPSS files. If I want to see an Excel file, I have to tell it to look for Excel file. And now I can see Excel files here on my desktop as well, including the one we were just working with in SPSS. So I can open this and have it import that file into SPSS. And it asks me some basic stuff, like for instance, it sees data between A1 and B21. There must be some blank something. Oh, that's all that. There's I don't know what's in B21. Might be some detritus or something like that, or I might have put a space into one of those things. But it's really A1 through B21 we're really interested in. I can say one of the things up here is read variable names from first row of data. Well, the first row was the name of the variable. Remember, I was working A2 to A21, so I want to make sure that I leave that clicked so it doesn't read that in as data, right? So it starts with the second row, which is the 57. If I unclick that, now it's going to include something else, V1 or something. It's going to include something else in there besides the 57. So I want to make sure that it's clicked. Okay, I'm going to click OK, and it's going to open the file in SPSS. Scores, it's going to take that top row and use that as the variable name. Okay, so the other way I could open this was I gave you actually a copy of the SPSS file. Right, there is the SPSS file there, right there. So I could open it that way as well. Just another caveat on the Excel file. If you have the file open in Excel, it will not open in SPSS. You have to close the file in Excel before you import it into SPSS. That's a quirk in SPSS that's been around for a while. See, so it comes in exactly the same. You could use either one of these two, the one that you import yourself or the one that I gave you. You could use either one of them. So now we want to calculate these descriptive statistics, the same ones that we did using Excel. So I'm going to go up here, as I do in most cases. I'm going to go up here to Analyze, Descriptive Statistics, and I have a couple of choices here. One is frequencies. I'm going to click into that for a moment. Frequencies is counts. You remember where we were looking at frequencies when we were looking at that histogram? Frequencies are counts. Normally, you use what's in this particular function. You use for categorical data. If you're collecting data on how many people are left-handed versus right-handed, you want to know 27 people are left-handed, 88 people are right-handed. You're doing counts. You're using categorical variables. Most often, we'll use frequencies for categorical variables. But we're dealing with a numerical variable here. So I'm going to go to Analyze, then go to Descriptive Statistics. I'm going to bypass frequencies and go to descriptives instead. Now, descriptives, I can click on here, and it's going to list all the variables that are in this data sheet on the left-hand side. I can say to myself, okay, well, which variable do I want to work with? And I can tell Excel, I can tell SPSS, I want to work with this particular variable. In this case, there's only one there, so not a lot of options here. I can click under Options, and I can tell it, well, it's already going to calculate standard deviation, minimum, maximum. Let's calculate the variance. Let's calculate the range. And that's about all it's going to give me here, isn't it? I'm going to click OK. So it's going to pull up an output window. This output window is always going to have where our calculations, our results of our calculations, the charts that are generated, are going to wind up going. And in fact, look, it says, oh, look, there's 20 people in this sample. The range was from 37 to 57. That looks familiar. The maximum was 94. The mean was 77.7. The standard deviation was 8.4. The variance was 71.3, and so on and so forth. Boy, that looks familiar, right? It looks like exactly the same thing we calculated before, except in this case, it's much more efficient. It does it in an instant or two. There are some things that we don't have here, aren't there, that we did before? Okay. Actually, Jenny, you mean import into SPSS? Did I do what you needed to know? Is what I just did, is what you were after? Okay, good, excellent. Okay, now the other problem I have here is that there's some things I was interested. I'm sorry, we can't see that. I'm lost. What can't we see? Oh, now we can. I'm sorry. I must have clicked away, or maybe when I clicked away, it did something. Okay, so at any rate, let me now there's some things here that we didn't calculate that we wanted. So I'm going to go back to my data set. I'm going to say analyze descriptive statistics. There is another selection below descriptives called explore. Okay, and again, we have one box here where one variable in this particular data set. So, oh, I'm sorry. Okay, I must have blocked it off with something. So one box here in this particular data, one variable here. So I know that's the only one I'm going to work with. So I'm going to move that over. I'm going to click on statistics, and it's going to tell me, oh, descriptives. It's going to just, there's not a lot of choices here, just descriptives, and then confidence intervals, something we're going to work with later on. Okay, I'm going to say continue. I didn't have many choices there. Plots. Oh, well, let's see. It's going to do a stem and leaf plot. We'll talk about that. Let's ask it to do a histogram. What do you know? How about a box plot? We want to know a little, dirty little secret. It's always going to produce a count. Now, when you go into Explore, it will always automatically produce a box plot for you. Down here, it gives me the option of just getting statistics, the numbers, or getting the plots, just the plots, or getting both. I'm going to leave it clicked on both. So I'm going to click OK. But I'm not going to worry about these other two boxes. I'm going to click OK. And now, instead of just calculating these statistics, it does a much more extensive job of calculating statistics. Mean, median, confidence interval, later on we're going to work with that, variance, standard deviation, minimum, maximum, interquartile range, and some other stuff that has to do with that, whether it's normally distributed. We'll be dealing with that later on. It created a histogram for me. So we can see that so many student scores were between, I guess, 65 and 70, so many between 80 and 85. It kind of automatically makes the bins. These are called bins. The range or bins automatically chooses its own bins. You can change that if you want to, and deal with the bins. Stem and leaf plot. The way that this works is that it takes the first digit of the value. So we got a student that got 69, and a student that got 66, and a student that got 69. So it starts with 6, and we have a student with 66 and a student with 69, and then we got a student that 4 students that got in the 70s, so 71 and 72, 72, and we got 5 students that got in the upper 70s, 77, 78. So basically, if you look at this, it forms a histogram very similar to the one that we see here, right? And that's kind of a way of doing this if you don't have making a histogram if you don't have graphics available to you. Kind of archaic. I wouldn't worry about it. You probably never use it. And look, it created for us a box plot, right? And the bottom leaf represents the lowest value. The upper leaf represents the highest value. The dark bar in the middle represents the median or 50. Oh, hey, Rebecca, which part of the screen, which part was, yeah, it's probably a lag. Hopefully it's recording okay. It might be, did anybody else experience that? Because it could be like on your internet connection. Did you guys, other guys experience a lag there? Or it could be mine. Oh, for a second. Okay. Oh, hopefully okay, good. Yeah, I think it should be in the recorded version of this. Okay, so at any rate, if you look at this, this is the minimum score, that's the maximum score, and the difference between the top of this and the bottom of this is the 25th percentile and 75th percentile. So again, 70 something and 80 something and so on. Now, it did do something a little funky. It took one of the values and separated it out from the box plot, right? Anybody know what that means? Why it did that? Right, that's an outlier. Somebody didn't study for the test, or maybe they had the flu that day. Maybe there's some reason. Maybe they had to leave, that an emergency, had to leave in the middle of the test or something like that. That number is very different from the other values. So SPSS decided, based on its own rules, you can change the rules if you want, then I'm going to display that as an outlier. That's a piece of data that someone should evaluate to decide whether you want to include it in this study or not. In other words, why is it so different, right? And if it's so different because there's a reason that would impact whether or not you should include it in the study, then you might want to remove that from the study. But you have to make that decision independently, right? You have to figure that out. But this is the way SPSS. Yeah, that's okay. SPSS, in Excel, an SPSS calculate the interquartile range slightly differently. Okay, and there could be a couple of reasons for that. One reason is that, for instance, SPSS may not be including the outlier. That's possible. Where in Excel you included the outlier, right? The other reason is because there's differences in the way that it calculates it. For instance, one way of calculating it might be to find the median, find the lowest value, and then find the person that's in the middle of that, and then average the two of them, kind of the same way you would do median. If there's an odd number or an even number, do exactly the same thing. And the other one is to take the standard deviation and the mean that you calculated, assuming this was a basically taken from a normal distribution, a normally distributed population, and then calculate the 25th percentile and 75th percentile based on the way you would expect a normally distributed population to uh, 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 be spread out. Okay, so long story short, for the time being, that's something we're going to approach in the future. For the time being, I wouldn't worry about it if they come out a little bit differently on Excel and SPSS. It's part of the process. Okay, so anyway, so that's what we would do there. Now, the next thing we asked you to do was to work with a more complicated file in SPSS. I'm going to close the output window. I'm going to go and say open data, and I have it on my desktop. It's this North Carolina birth file. I'm going to open that up, and let's see what I have here. Well, now I have all sorts of variables here. These variables have been coded for you already. In other words, each one of these columns represents a variable: gender of the infant, mother's age, the amount of weight the mother gained in pounds, the birth weight of the baby in grams, birth weight of the baby in ounces. Was the baby premature? Now let's go back to the variable view, and we can see that if it's a numerical variable, right? We have the mother's age, for instance. It's displayed as a numerical variable, number, right? In other words, a one or a two, an actual number, the mother's age in years. And it's a scalar variable. It's been identified by SPSS. The gender of the child is a nominal variable. It's either male or female. If I click into the values box, I can see another box. I can click in there, and one is male, two is female. If you want to be really modern, we could add another one of these and say not determined at birth or something like that. Something of that nature. And you could add another variable here. I'm not going to bother doing that here. Okay, that's an example of a binomial variable. It could have two values, right? Premature. One of these is called preemie. Where is it here? I think it's here. It is preemie, right? Preemie represents a premature infant, and that again is a dichotomous variable. It's categorical, right? One or two values. Not premature, was premature, right? So there's a lot of ways that we can work with this data. Okay, but we want to identify it as nominal, right? Ordinal or scalar. I don't think there's any ordinal variables here, but there's certainly a few scalar and nominal variables. So you identify what the number that represents that in the values, and you only do that, you only bother doing that for the uh, 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 for the categorical variables. You don't do that for the scalar variables. Weeks of completed weeks. Now notice completed weeks of weeks is completed weeks of pregnancy, right? That happened to be a integer. Those are all integers, right? Completed weeks of gestation, right? And SPSS incorrectly identified that as a nominal variable, right? That's really a numerical variable. So I'm going to change that right now. Okay. So as you go through this, you might want to check out. These are the ones that SPSS kind of stuck in there originally, but you might have to check them out as you go through. So I'm going to go back to the data view. And one of the things that we asked you to do here was to summarize a numerical variable, find the descriptive statistics for a numerical variable. I don't remember which variables they were. I'm going to choose my own. It'll work the same way with the ones that we asked you to choose. So I'm going to go to Analyze, and I'm going to say to myself, Descriptive Statistics. Now, I'm going to go into Descriptives. And I'm going to say, I want to know the average age of the mother. So I have a whole bunch of choices now. So I'm going to pick average age of the mother. And notice, I want to go back here for a second. Notice that the variable name, MAge, represents the mother's age. But if I go to the variable view, there's a column there with a label that's called label, where I can tell it what to call that variable so that when we produce a chart or a table, it doesn't have a mage on it, which means nothing to anybody but us, but instead uses the label that we told it to substitute for that, called age of the mother. Now you couldn't put this here as your variable name because SPSS will only accept letters and numbers for variable names with no spaces in them and no special characters. You couldn't have the parentheses. You couldn't have the spaces. And besides that, you got to start also. You got to start with a letter, not a number. So it's a little restrictive in terms of how you can describe it. So that's why you have that label thing there, so you can be a little bit more descriptive. So I'm going to go up here to Analyze, Descriptive Statistics. I'm going to go to Descriptives. We're working with a numerical variable. I'm going to say Age of the Mother. I'm going to move it into Variables. I'm going to click on Options. And yeah, let's do variance again. Let's do range. That's about as much as I think we want. I'm going to click OK. And SPSS does that calculation for us. Okay, 800 women, 800 births rather. The youngest woman was 15. The oldest was 42. The range was 27. The difference between those 27 years. The mean was 26.92. Standard deviation. The variance. I don't have the median here. It doesn't calculate the median. Maybe I wanted to know the median as well. Well, we know we can always go back here to Analyze, Descriptive Statistics, and instead of going to Descriptives, go to Explore, and we know that'll give us a bit more information. I'll move the age of the mother in here and make sure it's checked off for descriptives, right? And I know it's going to produce a box plot automatically, so I'm going to leave that alone. I'm going to click OK. Okay, so what do I got now? Well, I got all this other stuff that I calculated before, plus now I have my median, right? I have more statistics than I would have gotten otherwise. Look at that interesting stem and leaf plot. If I had done a histogram, it would look like this except vertical. If I checked off histogram, it would look like that except it would have been vertical. Matter of fact, let me do that. Analyze, descriptive statistics, explore. It's going to remember all the stuff I checked off before already. I'm just going to add histogram to this. And you'll see that it'll pull up the output table, output thing again. And here is my histogram. And it looks fairly normally distributed, except maybe there's some, it might be a little right skewed because there are some women that are quite a bit older than the average, right? So, but not many that are younger than the average. So the median might be somewhere around here, but these few older women that are further out, they might pull the average, might pull the mean to the right away from the median, right? So the middle value doesn't change much because you have a few older women, but the average is pulled away, these extreme values pull the average away from the middle value, the median, right? So that would be right skewed, very slightly right skewed, I think, right? Or positively skewed would be another way to describe that. And here is our box plot. Youngest woman is 15, the oldest was 43, it's 42 or 43. This was a while ago. We have older births now, right? The median, the middle value, was about 27, right? But look at this. It looks like we can see right here that these older women are pulling this value up, the average value up away from the median. So we can see this looks like it's positively skewed to higher values slightly, right? In other words, the average is going to be higher than the median. Let's take a look at that when we look at the numbers. When we look at the numbers, the median is 26 and the mean is 27. Right, so indeed that's what happened there. It's right skewed. Okay, so now the next thing I ask you to do is to take a look at dividing this up into groups. Perhaps our young, unmarried, married, are if I look at the two groups, married and unmarried women, what do you think would be the average age in those two groups? Would it be the same or would it be different? So let's take a look. Let's actually use SPSS to analyze that. Analyze descriptive statistics. Well, I know if I go into descriptives, I only have one thing I can do, just move that age over. I can't get anything else out of it. But in Explore, I noticed there were extra boxes, so I'm going to click on that. Age of the mother is already in here. Well, there's also a box here, factor list. In other words, we could take a categorical variable, like the race of the mother, marital status, smoking, smoke during pregnancy, and we can look to see if women that smoked during pregnancy tended to be older than women that didn't smoke during pregnancy. In other words, we can divide up these women into smokers and non-smokers and see what the average age was in each of those two groups separately. I'm going to do that. I think that might be interesting. Let's see. Smoke during pregnancy. We move that into the factor list, and let's see if there's a difference. Again, statistics already checked off. Plots, histograms already checked off if I want it, and so on and so forth. It's going to display both. I'm going to click OK, and let's see what I get now. Okay. There were 684 women who did not smoke during pregnancy, 114 who did smoke during pregnancy. This is a number of years ago, so these numbers are probably a lot different today. And remember, this is a random sample from tens of thousands of births in North Carolina. So the mean age of mothers who did not smoke was 27. The mean age of mothers who did smoke was 25.7. So the younger mothers seemed to be more likely to smoke than the older mothers were. In other words, the average age of mothers who did not smoke was older. So the older mothers were more cognizant of not smoking during pregnancy, it seems like. Now, whether or not this difference is due to chance or is a real difference in the whole population of tens of thousands of births is something that we're going to learn about trying to prove as we move forward in this course. As a corollary, we have two histograms now. We have a histogram where mothers didn't smoke, mothers who did smoke. It actually divides the two groups up and does all the statistics for both of them. And most interesting of all, it actually produces side-by-side box plots, so we can compare them very easily. So the median age for mothers who did not smoke is about 27. The median age, not average, but median age. I think we were talking about average before. Median age for mothers who did smoke during pregnancy was about 24 or 25. Right, so we can see it's quite a bit of a difference there. See that there's a little less variability here in age ranges than there is in this group, and so on and so forth. And I could have done this equally well for the statistics for. I could have also compared the age of the mother based on whether they're married or not. Marital status. Could have done exactly the same thing and gotten statistics for that. Okay, now, one of the things, marital status, age of the mother, we have a lot of outliers there, right? So not married, you have a lot of women that were, you had most of the women that were not married were younger when they were pregnant, and so it saw a lot of the older ones as outliers. Very kind of odd distribution of data here. So, but you can see that. Now, one of the other things I asked you to do is that for the last two questions, rather than have you give me an SPSS output file, which, different versions of SPSS may not be able to open and so on and so forth. The older version might not be able to open that file, and most people will not have SPSS on their computers. So if you want to communicate this to people that you want to see this data, you can take these charts and these graphs, any one of them, highlight them, say copy, right? Go up here and say copy. Or you can just say Control C, right? Or whichever kind of computer you have. Or you can say, let's say, highlight a chart, say copy, or Control C. Open up Microsoft Word or some other word processing program and paste it into that document and save that document. And the reason why I asked you to do that, because in the future, that's the way you're going to be using this. If you're doing a report or a paper or something like that, you're going to want to be able to communicate this as part of your paper. So you actually can paste in these charts and tables into your paper or into your document, say save as, and then you can upload this to Blackboard as the answer to that question. Okay, so I think we beat this to death. I want to just quickly just open up assignment 2 so you can kind of get a little bit of a preview on it, but it's not due until Wednesday for some of you, later for others, so I just want to open it up. We're running a little later than I hoped for, so I just want to open it up so you guys can look at it. So I'm hoping this helps. I'm not going to bother saving this. I'm going to close this. So change nope. Okay, let's see if I can quit this. Say contents. Nope. Okay, so any other questions here? So let me just open this up quickly. I think this is 2. Nope, this is the same one. I just opened up the same one. Maybe it's this one. Yeah, this is 2. Okay, so now in this one, you guys all still there? I think yep, you're all, a lot of you are still there. Okay, good. On this one, we get into starting to talk about the probabilities and so on. Prevalence of diabetes, 10%. You randomly select 3 independent subjects from a population, which probably all 3 are diabetic. Well, remember, 10% times 10% times 10%, probably all 3 of them are diabetic. Since it's independent, since an independent random sample is going to be 0.1 times 0.1 times 0.1. You can calculate that. Okay, prevalence, it's probably none of the 3 are diabetic. Well, probably any one of them is not diabetic is 90%, right? So 0.9 times 0.9, so on. Okay, you guys can figure that out. 60% of the population, okay, and this one is going to test you a little bit to ask you to figure out, well, based on what you know about that, what would you expect the result be if you took repeated samples of size 3? What kind of results would you expect to see? Now, Venn diagram, some of you have seen this. You guys that are online, in the online class, have seen a video on this, but you can see this Venn diagram represents all the values that are in B, for instance. Right, and it also includes some of the people. There's some intersection with A also, but these are all B's that are here. Okay, and this one represents union of them. I'm not going to go into this. There's a video on Blackboard. You'll have a video on Blackboard that'll discuss this, so you can learn to interpret these Venn diagrams. They'll wind up on the exam. I don't think you'll see too much of these as you go to the future. Hang on a second. I'll get back to question 1 there in a moment. And now diagnostic tests. Okay, so here's a population. Here's a diagnostic test that wound up. This is a diagnostic test for cooties. Either you have cooties or you don't have cooties, right? Imaginary disease, right? So we're working with a diagnostic test, right? So in this diagnostic test, we tested on people, a population, then we followed up gold standard test, so we know which of them really had it, which didn't have it. We found that in a random sample of 1,000 people, 100 people had this condition, right? So the prevalence is 10%, right? That would be the prevalence, would be 100 out of 1,000, right? The total number of people who have the disease out of the total number of people that you sampled, that would be the prevalence, that would be percentage of people that have it. Okay, now we took our diagnostic test, right? And we said our diagnostic test, out of those 100 people that have the disease, how good was it at predicting that, right? Well, we see that out of those 100 people, it got it right 80 times, right? Out of 100. So our sensitivity is 80%. 80 out of 100 times it got it right. 20 out of 100 times got it wrong, said that they were negative, right? Okay. Well, how about the prevalence of the specificity of this test? How good is it at identifying people who don't have the disease? Well, 900 people don't have the disease. And in 810 cases, it correctly predicted that, right? In 90 cases, 10% of the cases, it got it wrong. It said they had the disease, that they were positive, right? So the specificity was 810 over 900, the percentage of time they got it right, that they were negative, and that's 90%. So the sensitivity was 80%, the specificity was 90%. Okay, so now we're interested in, once we use this test and you have a result, what is the predictive value of this test? In other words, if you take this test and it says you're positive for this disease, right, what's the probability you actually have it? Okay, well, let's see. How many people tested positive? 170 people tested positive. Out of those 170 people, how many really had the disease? 80 of them had the disease. So 80 over 170 is the positive predictive value of this test, right? So what's a negative predictive value? Well, similarly, 830 people tested negative. Of those, 810 were actually negative. So the negative predictive value is 810 over 830, which is probably like 98% or something like that, right? So that's a negative and positive predictive value. The important thing to recognize here is that the positive predictive value, negative predictive value, they're conditional probabilities. Given that you tested positive, what's the probability that you actually have the disease? That we're only going to work with the top line, or we're only going to work with the bottom line. Okay, so that's important to understand about this, that idea. You can also calculate the positive or negative predictive value by using this formula, which is really just another way to do this calculation with these boxes. Right, so I'm not going to go into too much of that. You have a few more extra days on that, but please get started and get complete on homework number one. I really would appreciate that. So at any rate, so let me go back to that question that just came up about question number one. Was it question number one on which, on this or on the homework number one? On assignment. Oh, question number one on assignment two. Okay. Let's say we flip a coin. Probability of getting heads on a coin is 50%, right? 50-50. Might get heads, might not get. Half time you get heads, half time you get tails. Okay. When you flip a second coin, the coin doesn't remember what the first flip was, so the probability is still the same, 50%, right? And if you flip a third coin, doesn't know what the first two coins did, so the probability is again 50%. Now, that probability stays the same. But what if I ask you, what's the probability before you flip any coins? What's the probability you flip three of them and all three of them come up heads? Well, you're predicting that in advance of flipping all three coins. So the probability of the first coin being heads is 50%, second one 50%, third one 50%. So the probability of getting all three to be heads before you even start is 0.5 times 0.5 times 0.5. 1 over 2 times 1 over 2 times 1 over 2, or 1 over 8. That's 12.5%, 0.125, or 12.5%. Now, probability of getting tails is the same thing because it's 50%, 0.5 times 0.5 times 0.5. When you're with the diabetic population, the probability of if I have a population that has a 10% likelihood of someone in that population having diabetes, in other words, prevalence is 10%. the probability, if I pick a random person out of that population, probability that they have diabetes is 10%. Now, if I take another random person, in other words, second person has nothing to do with the first, and I say, what's the probability of that second person? It's going to be 10% again. I take a third person, completely independently and randomly from the first two, it's going to be 10% again. But if I asked you, if I take three people at the same time, randomly selected at the same time, I don't know what their status is, and I want to know what's the probability of all three of them having diabetes, it's going to be 10% times 10% times 10%. Similarly, if I turn that around and I ask you, well, what's the probability of picking three people and all three of them not having diabetes? Well, the probability for the first person is 90%, right? The opposite, the inverse of that 10%. And the second person is 90%. The third person is 90%, right? But if I take them one at a time, it's always going to be 90%. But if I randomly select three people together and say, what's the probability all three of them are free of diabetes? It would be 0.9 times 0.9 times 0.9. Okay, I hope I answered that question sufficiently. Okay, and using that knowledge, figure out if there's a problem with question 3. I want to challenge you with that particular one. Okay, guys. So I'm going to call it a day. I'll get this posted hopefully within the next few hours, and I hope it helped out. And thanks for attending. It's always nice to have people to talk to. Believe it or not, even though I can't see you, I sense that you're there. It's much more comfortable doing this than if there's nobody there. Trust me. Take care, guys. Have a good day.